Bonjour everyone, my name is Thomas Vinadel and today I'm going to show you how to implement 3Cs in Unreal Engine 5. In this tutorial, we're going to see how to implement 3Cs with a lookup with the mouse, a jump on the spacebar, an idle walk run with WASD, a sprint with the shift key, and a camera that will be able to turn freely around the character. First, what are 3Cs? 3Cs in the video game industry are the way you're going to represent your character to the player screen. To explain this to you, I'm going to use the puppet representation. The first C stands for character. Basically, it will be how your character will look like. So it's going to represent by its skin, its animations, and its collisions. In the puppet representation, this will be your puppet. Next, we're going to have the controller. Controllers are made of two things. First, your gamepad inputs. This will be every input that are triggered with your keyboard, mouse, or your gamepad. This is your hand. And next, we're going to have the controller script that will transform every input into gameplay. Those are the wires. And finally, we will have the camera. The camera is how you're gonna render your character into the player screen. And for that, we're gonna need a camera and a spring arm. This is the eye of the puppeteer. To begin with, our character will need a skeletal mesh. You can get it from the Epic Games Marketplace or from your personal work, but here in this tutorial I will show you how to get it from Mixamo. Once you're logged in, click on the Character tab and look for the character you want to implement in your project. For me, it's gonna be this alien soldier. Click on Download, and here we're gonna keep the default settings, FBX T-pose. Try to download it into a folder that you can easily find. Once you have your location, try to give an accurate name to your downloaded asset. Now, let's get the animation by clicking on the Animation tab. First, we're gonna look for an idle animation. When clicking on Download, take care to take the Without Skin option, because we already downloaded the skeletal mesh. Now, let's look for a walk animation. When working on video game, we want static animation. So take care to check the in-place boolean when you download a walk or run or sprint animation on Mixamo. Now, let's search a run animation. And last but not least, the sprint animation. Now let's do the jump. In the video game industry, we wanted to have a 3-part jump with a begin, a loop, and an end. So let's search for the jump begin. Now, let's find a jump end that will be used as a landing animation. And to finish, we're gonna look for our falling loop. Now that we have all our skeletal mesh and animation, let's implement them in Unreal Engine. First, open the content drawer and create a new folder called Character. Let's begin by integrator skeletal mesh. Just drag and drop it into your content drawer and it will open the integration pipe. There's a lot of setting into this integration pipe, but for us, we just want to uncheck the import animation because we're gonna implement them later. But still, if you want to take a look, you're free to go. Feel free to pause the video. One important thing is the import setting that you can find below the box. But let's import everything. Once it's done importing, you can see a lot of assets showing up. Those are all parts of your character mesh. By double-clicking on the pink asset, you can see the whole skeletal mesh integrated. Because there's a lot of assets, it can be quite a mess for your team to work with those. So I recommend you to reorganize and rename every asset. For me, I'm gonna use the Unreal Engine Marketplace naming convention to rename them. Feel free to pause the video while I organize and rename every asset. Now let's import our animation. First, create an animation folder. Import them by drag and drop them into the content drawer. And here comes the integration pipe. Here, we want to check again the import animation boolean. But as you can see, we are not able to import our animation because as it says, we need a skeleton reference for it. So let's search the skeleton into our pipe and reference the skeleton we previously integrated. Now that our animations are integrated, let's rename them using the batch rename tool of Unreal. This will allow me to add the prefix AS underscore for animation seconds, as the Unreal naming convention wants me to do. Now, let's implement this animation into a character blueprint. Right-click in the content drawer, blueprint class, and we're going to create a character. Let's name it BP underscore alien soldier. Open it and let's integrate our skeletal mesh. First, click on the mesh component into your component tab. And then at the right on your detail tab, you can find your skeletal mesh here, and we're going to select the one we integrated. Now, let's put it inside our collision capsule and make it face the arrow using the transform of our component. When it's done, click on the capsule component of our character and resize it to make your character fit perfectly inside of it. Now, our character mesh and collision are perfectly integrated into our character blueprint. We can now program the animation of our character. In our animation folder, right-click, go to Animation, and create an animation blueprint. This will require the skeleton we integrated before. Search it and select it. We'll name it ABP underscore alien soldier. Once it's done and open, let's see how it works. At the right of your screen, you will be able to see your asset browser, where you can find all the animation referenced with this target. Drag and drop it, connect it to an output pin, compile, and you will be able to see your animation running. To connect it to the character blueprint, let's click on our mesh component, select Animation Blueprint, and select the animation blueprint we just created. When you compile, you can see that your animation is running, but it's not looping, and we will be able to do only the idle. That's because in our animation blueprint, we only connected the idle animation. To connect the idle walk run, we will need a specific kind of assets. Let's delete this and create what we call a BlendSpace. Right-click, Animation, and here you can find the BlendSpace. But this one will be defined with 2 axes. We just need one. So we're going to go to Legacy and select the BlendSpace 1D. Let's select our skeleton, and we're going to call it BS1D underscore locomotion. When you open it, you will be able to see the axis that I told before. This is a 1D axis. Let's set it up by giving it a name, and we're going to put its maximum value to the speed of our character. To find it, we're going to check the character movement of our character. This component will allow us to set everything that is connected to the movement. Here, the max walk speed is set to 600. That's what we want. So let's set the maximum value to 600. You can now see that our maximum value in our axis is now 600. For a better manipulation, we're going to divide this grid by 25 and we're going to snap our animation to this grid. Now, let's add our animation to our grid. The idle goes to 0 and the run goes to 600. By holding Ctrl, you will be able to preview the animation of your character by its speed. To finish this, let's put our walk at the middle of our line. We now have an idle walk run BlendSpace ready to be used. But still, if we change the speed in one frame, you can see that the animation will snap. This is not smooth. So let's add a little smooth time by 0.2 seconds to make sure that our animation are blended smoothly. Let's now add our BlendSpace to our animation blueprint. Just drag and drop it as we did for the idle animation and connect it to the output pose. To make sure to control our BlendSpace, right-click on the input pin and promote this to variable. This will be the value that will drive our BlendSpace. Now that we have this variable into our animation blueprint, we can modify it and we will be able to see that the BlendSpace is correctly working. This newly created variable will need to be updated at runtime. So for that, let's go to the event graph in the update animation. Drag the return value of the TriGet pawn owner and cast it to BP Alien Soldier. This will allow us to get a reference to our character. We can now drag our as BP Alien Soldier output to get the velocity of our character. With a little math, we will be able to transform this velocity into speed by getting the vector lengths x and y of this velocity. We don't need the z because our character isn't flying. So now we just have to set our speed to this calculated value. Our idle walk run is now ready to go. Let's implement the sprint. The sprint in Unreal Engine will be programmed using the max walk speed that we've seen before. We're just gonna change this value to a higher value, for example 1000. This will be done at runtime. So this is how we sprint. So because 1000 will be our sprint speed, we need to update our BlendSpace to 1000 for its maximum value and put our sprint to this value. Our idle walk run now handle the sprint. You can see that if we change the value of the speed to 1000, our character is now sprinting. Let's do the jump animation. Let's get back to our anim graph, and to do that, we will need what we call a state machine. Let's rename it locomotion, and we can get rid of the BlendSpace that is already on our animation blueprint, because this will be replaced by our state machine. Let's double click on it to enter it. Here we will be able to create different states in which our character will be animated. So let's first handle the idle walk run again, double click on our state, and here we can put back our idle walk run. Let's get back to our locomotion state machine. Here we can add our 3 states of jump just by drag and drop them into our state machine. This will automatically create the states. We're now able to connect them by authorize the idle walk run to go to the jump start to the jump loop to the jump end, and the jump end to the idle walk run. You can see that the newly created connection has a little bubble. This is called a condition. This will allow us to create conditions to our transition. So here the purpose is to go to jump loop when jump start has ended. And for that, we're going to check the automatic rule boolean. And we're going to do the exact same thing for the jump end to idle walk run. For the jump loop to jump end and idle walk run to jump start, we will need some special condition. Double click on it, and here you can see that we can define a boolean by right clicking and promote to variable to control this transition. Here I'm calling it is falling. So when my character is falling, it's gonna go to jump start, and when my character starts falling, it's gonna go to jump end. So let's get our newly created boolean and invert it with the not boolean. This means that when my character hit the ground, it stops falling, so it must play its landing animation. Let's see if it works. As you can see, it works, but my animation is not looping. Let's fix that. Double click to enter our jump loop state. Click on the animation sequence, and on the detail, you can find the loop animation boolean. Let's check it. Now it works perfectly. But still, we need to make it work at runtime. So let's get back to our event graph. Next to our speed into our update animation, let's grab our BP alien soldier and get the character movement. We did this because, as I said before, the character movement is linked to every movement mode of our character. So the falling is considered by the character movement. This means that by getting the character movement, we can ask it if my character is falling. Now we just have to set our isFalling boolean to our isFalling variable. With all of that, we now have a character that is able to jump and to run. And everything will work in runtime because of our update animation code. Now our puppet is ready. We learned how to integrate its skeleton and its mesh, its animation, we programmed this animation to do an idle walk, run, and a jump, and we define its collisions. Now, let's program the controller. To program our controller, we will need some specific assets. So let's create a new folder that I like to call _game_manager to keep it at the beginning of my folder hierarchy. And in it, we're gonna create first a player controller by clicking on blueprint class and player controller. I will name it PC_alien soldier. Now, to capture our gamepad input, we will need some specific data assets. Let's create first the input mapping context by right-clicking, going to input category, and clicking on input mapping context. Let's call it IMC_alien soldier. This input mapping context will handle all the mapping that we're going to do for our gamepad. Those mapping will require some specific data assets that are called input action. So let's create them. We will need one input action for every binding that we need. So let's first create IA move, then IA look, then IA sprint, and IA jump. Now we will need to configure them, because if IA sprint and IA jump are just Boolean statement, true or false, the move and the look will be different. They will need to be able to tell if I'm going up, down, left, or right. So let's open them. In the input action, you can see that we have here a value type. The Boolean says true or false, but in my case, I want an axis 2D, so I can tell it if it's up, down, left, or right. That's the only thing we're going to modify. Let's do the same for IA look. As I say for the jump and the sprint, it's just a true or false statement, so we're going to leave them in Boolean. Let's now implement them into the input mapping context. Here we have an array. This array will contain every input action that we created before. So let's add our first input action by clicking on None and adding our input action move. If you click on the arrow at the left of our array element, you will see our binding that we're able to put. Let's first make our binding for the gamepad by adding the left thumbstick on its 2D axis. Let's now add our input for the keyboard by adding our W, S, A, and D input. You have this button that is a listener. If you click on it and then press the input on your gamepad, it will reference it automatically. Our input are ready, but remember that our input action references a 2D vector. For the thumbstick, it's already done. But for WASD, we will need to tell in which direction each input is going to go, because the keyboard will only return a Boolean. For that, we're going to use modifiers. By default, this input is on the positive X value. So we need to swizzle the input axis value to put it on the positive Y axis. For the S input, we will need to swizzle the axis again to put it on the Y axis, but we will need to negate this value, so it will be put in the negative Y axis. For the A, because we already are on the X axis, we will just need to negate this input value. And because the D is already in the positive X value, we won't need to change anything. Our IA move is now ready to be used. So let's now add our second input action, which is the IA look. Just as the move input action, let's add our gamepad right thumbstick to the axis. For the keyboard mouse, we're going to look for the mouse X, Y to the axis. Because our input action is defined on the 2D vector, the 2D axis of both our input are just ready to go. But if you want to, we can add a negate to the mouse to invert the camera control on the X or the Y axis. We won't do that here because to give the possibility to the player to control the invert camera axis, we'll need to program it in the player controller. Now that our IA look is ready, let's add our third input action, which is the sprint. I will give it the gamepad left thumbstick button for the gamepad, and the left shift for the keyboard mouse. Finally, let's add our last input action by adding the IA jump. This will be the face button bottom of my gamepad. And the spacebar for the keyboard mouse. Our inputs are now ready to be used in the player controller to be transformed as gameplay. So let's open our player controller. Here we need to connect our input mapping context to the player controller. To do so, we will use an event that is called onPossess. This event will allow us to connect our input mapping context when a character is possessed by this player controller. And because the onPossess event will fire when a character is possessed, I will be sure that everything is set up. So search for the enhance input local player subsystem. Just be sure to take the one that is in the local player subsystem category. We need this subsystem because the input action and input mapping context are contained into this enhance input subsystem. So let's grab it and search for add mapping context. Connect it to our event onPossess and reference our IMC into the add mapping context. Our IMC is now connected to the player controller, which means our input action will be able to fire into this player controller. So let's select them and drag and drop them into my player controller. This will create our event for input action to be fired. We can now program each behavior connected to this input action. First, let's program our IA move. So this event will fire when our input is pressed. Let's begin by breaking my vector action value into X and Y value so we can use them. And now we're gonna need to add a movement to our controlled pawn. But if we try to get the add movement input right here, we can't find it because we're in the player controller. We need a reference to our controlled pawn. So let's right click and search for get controlled pawn. Because our input mapping context is added on the onPossess event of this player controller, I'm sure that my controlled pawn is good. So let's now find the add movement input. Let's duplicate that so we can move our character on both our axes. We can now take back our breaked action value and manipulate the X and Y value. The X will be the A and D, and the Y will be the Z and S. So that means the X here is gonna be our right movement. And of course, the second one will be our forward movement with the Y axis value. We now need to reference the world direction of each our movement. For that, I will get the get desired rotation node from the controller, which allow me to have the correct rotation for my movement. Now, all I have to do is get this rotator and get its right vector, so I have my world direction. Let's do it again, but this time with the forward vector instead of the right vector. We now have a complete movement that is ready to be used on our controlled pawn. Now we turn to the IA look. Let's bring it. Once again, break the action value. And let's search for add pitch input so we can manipulate the rotation of my controller. It is used to manipulate the look up of my controller, and let's add a YOD input to manipulate the turn of my controller. Here, we need to manipulate the rotation of the controller and not the pawn, because the camera control is directly linked to the rotation of my controller. We will see in the third part of this tutorial how it works. But for now, let's just plug the X into the yaw, the Y into the pitch, and connect everything to my input action look. Remember when we configured the input action, I said that we will negate the look up of my mouse using the controller. This is where we're going to do it. Grab the Y and add a multiply. Let's plug this into my add pitch input and multiply my Y axis value by -1. Here we hard-coded the inverted camera, but I want to give the control to my player. So instead of the -1, let's add a select float. This node will allow me to select a number using a boolean. So if my boolean is true, I'm going to select the A number. If it's false, it's going to select the B number. So let's add -1 to the A and 1 to the B and promote to variable our boolean. Let's call it invert camera. For my game feel, I like to have the inverted camera by default, so I need to put this boolean to true. But if I want to do this, I first need to compile my blueprint. So let's do that and check my invert camera. My camera is now inverted and we finished the camera control. We now still have to do our sprint and jump. Let's first do the jump. It's pretty easy to do a jump in Unreal Engine, because everything we need is stored in the character. To access it, we just need to get the control pawn. Let's now open our BP Alien Soldier. If you have this view, just click on the Open Full Blueprint Editor, click on Class Default, and in the Detail panel, search for Jump. Those are all the configurable variables that you have for your jump. Here you can manipulate the air control, the max hold time, the max jump count if you want a double jump, and all of that because our BP Alien Soldier is a character. But here, the get control pawn returns us a pawn. So we can't have access to our character because of that. But let's take a look of the legacy of the character. Create a new blueprint class and search for character in all classes. Here you can see the legacy of the object, actor, pawn, then character. Which means that my character is a pawn. So here we just need to transform my pawn into character by using a cast to character. This will work because my BP Alien Soldier is a character and my character is a pawn. Now that we have a reference to a character, we can search for the jump event. That's all we need to do for the jump. Let's finish our controller with the sprint. As I said before, we will need to modify the max walk speed when holding the sprint input, and then to bring it back to the default value when we release it. For that, let's open our input action. You can see various output: triggered, started, ongoing, cancelled, and completed. Each one of them have a different behavior. For now, we just use the triggered output. And its behavior is told by the trigger we define into the input action. The started will fire for every beginning of the input. The ongoing will trigger every frame during the trigger of my input. The cancelled will fire if the requirements of my input action is not successful, and the completed if it's successful. Here we will need the started and the completed, which fire when I press my input and when I release my input. Let's grab our get-controlled pawn. As I said, for the sprint, we will need to modify the max walk speed in our character movement. To be able to get the walk speed and the sprint speed properly, let's create two variables, one walk speed and one sprint speed, that we're gonna put into float. Let's compile so we can put our sprint speed to 1000 and our walk speed to 600. Those are gonna be the reference value of our speed. But let's assure us that our walk speed is the default speed of our character. For that, we will use the begin play, which is an event that fires only once at the beginning of our blueprint. Let's grab our character movement to set the max walk speed. Let's drag our walk speed and put it on the set max walk speed of our character movement. With that, the value as defined in my variable is the default one. Let's get back to our player controller. We will now need to access the variable we just created from this pawn. If I take a look to the legacy and search for my BP alien soldier, remember that my alien soldier is a character, which is a pawn, so I can cast it. Plug that into my started event, and we can now set the max walk speed of my character using its character movement directly from my controller. Because of the cast, I'm now able to get my sprint speed directly from my player controller. My sprint speed, which is stored in my BP alien soldier. You can see that if I search it from the get-control pawn, I can't access it because my actor is not in the right class. So let's plug this into our set max walk speed. We now have to do this for the release of our input, so let's duplicate this and plug it to the completed event. Of course, in the release, we don't want the sprint speed, so let's replace it by our walk speed. Our sprint is now ready to be used. And with that, we program all the idle walk run, sprint, jump, and look on our controller. Now, our hand and wires are connected to our puppet. But still, we don't have any camera to control. Let's do this. To program our controller, we will need some specific assets. So let's create a new folder that I like to call _game_manager to keep it at the beginning of my folder hierarchy. And in it, we're gonna create first a player controller by clicking on blueprint class and player controller. I will name it PC_alien soldier. Now, to capture our gamepad input, we will need some specific data assets. Let's create first the input mapping context by right-clicking, going to Input category, and clicking on Input mapping context. Let's call it IMC_alien soldier. This input mapping context will handle all the mapping that we're going to do for our gamepad. Those mapping will require some specific data assets that are called input action. So let's create them. We will need one input action for every binding that we need. So let's first create IA move, then IA look, then IA sprint, and IA jump. Now we will need to configure them, because if IA sprint and IA jump are just Boolean statement, true or false, the move and the look will be different. They will need to be able to tell if I'm going. To do our camera, we will need to access our character. So let's open our BP Alien Soldier. In the component tab at the top left of the screen, we will need two components. The first will be the spring arm. Its purpose is to hold the camera. And then we will need our camera. Take care to have the camera as a child of your spring arm. Now let's click on the spring arm and configure the view. The important thing is that we never use the location to move our spring arm. We only use the offsets that are given to us by the camera category. The purpose here is to have a great game feel. And if we modify the transform location of our spring arm, the game feel will feel broken. So now that we know the good ways to modify our camera, let's get back to our level and put our character onto the scene. This will give us this little preview at the bottom right, so we can minimize our BP Alien Soldier window and modify the settings of our spring arm by seeing the effects on the point of view. So let's set our point of view to be a shoulder view of our third-person character. Now that I have a pretty good view, I will now modify a little bit the rotation of my spring arm so I can have a better view. My point of view is now ready. Now we will need to test everything that we've done in this tutorial. For that, delete the character in our scene, and we're gonna create a little game mode so we can play our character. Let's get back to our game manager folder, right-click, blueprint class, and search for game mode in the all classes category. We want the game mode, not the game mode base, because the game mode has already everything instantiated for us to be playable. Let's give it a name beginning by GM_. And we can now implement it in our level. To do so, we will need to use the World Setting tab of our level. If you don't have it open, let's click on Window, World Settings. Now, in the Game Mode category, just select our game mode. And we can now tell this game mode to use our BP Alien Soldier and our player controller. We can now hit play and test our character. As you can see, our character is showing with its animation on the right point of view. But if I try to move left and right, you can see that my character is sliding on the ground. And when I move my mouse, my entire character moves. Let's change that. Let's get back to our BP alien soldier. And open its player controller. When we programmed the camera control, remember that we modified the control rotation of the controller. This means that in our control pawn, we will need to redirect this control rotation not to the pawn, but to the spring arm. For that, in the BP Alien Soldier, click on Class Default and search for pawn. You can see here the use control rotation booleans. This means that the control rotation will affect my entire pawn. Let's uncheck the rotation here. Then let's go to the spring arm. And let's check the use pawn control rotation. This will redirect the control rotation from my pawn to my spring arm. We can now move our camera freely around our character. But if I try to move, you can see that my character is not turning in the direction of its movement. Let's change that by going to my BP Alien Soldier, clicking on my character movement, and searching for Orient Rotation to Movement. Let's check that. Everything is now ready, and my camera is ready to go. Now, our camera is ready to render the character into the player screen, which finalizes our 3C implementation. To do our camera, we will need to access our character. So let's open our BP Alien Soldier. In the component tab at the top left of the screen, So this concludes our tutorial on the 3Cs. So we learned how to implement the character, the controller and the camera by integrating the character mesh and its animation using the animation blueprint and the character blueprint. We developed the controller using the input action, input mapping context and the player controller. And we defined the camera using the camera component and its spring arm. So tell me, what are you gonna do with this? My name is Thomas Vinadel, and I see you in another tutorial. Au revoir!